For the problem in this video, given is a hollow rectangular beam. Assuming F'C is 28 megapascal and Fy is 345 megapascal, determine the required steel area if the ultimate moment capacity is 800 kilonewton meter. Drawing ko lang ulit yung figure na given sa problem with the given value of F'C 28 megapascal, Fy 345 megapascal, and the ultimate moment capacity, Mu, is 800 kilonewton meter. Determine the value of AS. Step number 1, solve for the value of Mu max. Ano-ano ba yung alam natin na condition under Mu max? Under Mu max, alam natin na ang strain ng steel is 0.004, Fs is 800 megapascal, Cmax is equal to 3/70, and the value of reduction factor is equal to 0.65 plus 0.25 Fs minus Fy over 1000 minus Fy. Na-explain na to sa mga previous videos na na-upload ko. Solving for the value of Cmax is equal to 3/7D is equal to 3/7 multiplied by effective depth 725. Ito yun. Then the value of Cmax is equal to 310.714 mm. Solve naman natin yung value ng Amax para malaman yung magiging depth ng rectangular compression block. Amax is equal to beta 1 Cmax. But what is the value of beta 1? Since F'C is exactly equal to 28 megapascal, magpopol tayo dito sa section na to. F'C is equal to 28 megapascal. Then the value of beta 1 is equal to 0.85. By substituting the value of beta 1 and Cmax na nakuha natin, beta 1, 0.85, Cmax, 310.714, then the value of Amax is equal to 264.11 mm. Since the value of Amax is greater than 150 mm, dito papatak sa axis na to yung magiging depth ng ating compression block. Yun yung Amax. I-designate ko naman yung natitirang depth na to as say. Then say is equal to Amax minus 150. At ang makukuha value ng say is equal to 114.11 mm. I-subdivide ko lang yung area under compression into a common geometric figure with known location of its centroid. Kaya hinati ko siya sa area 1, rectangle, then this one is area 2. Solving per value of A1 is equal to this width, 500 times 150. Area 2 is equal to 125, yung width, times say, yung length, times 2, dahil same lang naman sila ng dimension. Area 1 is equal to 500 times 150 is equal to 75,000 mm squared. Area 2 is equal to twice of 125 times 114.11 is equal to 28,527.50 mm squared. Katulad na in-explain ko sa naunang problem, hatiin ko yung compression block ng section para sa compression block ng area 1 at yung compression block ng area 2. C1 is the compression block for area 1 and C2 is the compression block for area 2. C1 plus C2 is equal to C. Solving for the value of C1 and C2, C1 is equal to 0.85, F'C A1 is equal to 0.85, F'C 28, then A1 is 75,000. Then the value of C1 is equal to 1,785,000 Newton. Same as to C2, 0.85, F'C A2. Then the value of C2 is equal to 678,954.15 Newton. From this figure, apply summation forces horizontal. C is equal to T. Tulad na sabi ko kanina, C is equal to C1 plus C2. Kaya ang nagawa kong equation, T is equal to C1 plus C2. T is equal to AS max Fy equal to C1 plus C2. By substituting the values na meron tayo sa equation na to, ang unknown lang is AS max. AS max multiplied by Fy, 345 given, is equal to C1 plus C2. Then the value of AS max is equal to 7,142 mm squared. To solve for the value of Mu max equal to reduction factor Mn max. Inilagay ko na kanina yung formula ng reduction factor na gagamitin natin under maximum condition. This is the formula under maximum condition and the value of Fs in this formula is 800 megapascal. Substituting the values 0.65 plus 0.25 Fs 800 minus Fy 345 over 1,000 minus value of Fy. Then the value of reduction factor is equal to 0.824. Ang kukunin naman natin ngayon is yung value ng Mn max. Going back to this figure, the value of Mn max is equal to M1 plus M2. The value of M1 is equal to C1 times Y1 and the value of M2 is equal to C2 times Y2. Solving for the value of Mn max is equal to C1Y1 plus C2Y2. Nasolve na kanina yung value ng C1 and C2. Ngayon naman, ang isosolve na lang natin is yung value ng Y1 at Y2. Looking at this figure, since from this axis up to this axis is equal to effective depth or 725, then Y1 is equal to D or 725 minus 150 over 2. Then Y2 is equal to effective depth 725 minus 150 minus 114.11 over 2. Kaya magagawa natin equation is equal to C1, 1,785,000 minus Y1, 725 minus 150 over 2 plus C2, 678,954.5 725 minus 150 minus 114.11 over 2. At ang makukuhang value ng Mn max is equal to 1511.911 kN meter. Going back to this formula, Mu max is equal to reduction factor Mn max, reduction factor 0.824, then the value of Mn max 1511.911. At ang makukuhang value for Mu max is equal to 1245.81 kN meter. Para malaman kung i-design ba yung beam as singly or doubly reinforced, i-compare lang natin yung value ng Mu or yung moment capacity which is 800 kN meter sa value ng Mu max na nakuha natin. Since the value of Mu is less than Mu max, dito tayo papasok sa kategory na to. Kaya i-design natin yung beam as singly reinforced. After natin malaman kung i-design ba yung beam as singly or doubly reinforced, the next step is to solve for the value of Mu tension controlled or MUTC. When the beam is under tension controlled, ano-ano ba yung mga parameters na alam natin? The value of strain of steel is equal to 0.005, Fs is 1,000 megapascal, C at tension controlled is equal to 3 over 8D, and the value of reduction factor is equal to 0.90. Dito sa step 2, halos same lang ng process yung gagawin natin katulad ng sa step 1. C at tension control is equal to 38D, the value of D is equal to 725, kaya makukuha natin value ng CTC is equal to 271.875 mm. A at tension control is equal to beta 1 CTC is equal to 0.85, C is equal to 271.875, at ang makukuha value ng A is equal to 231.094 mm. Since yung value ng A is greater than 150, then the value of C is equal to A minus 150. Solving for C is equal to A, yung nakuha natin, minus 150. Then the value of C is 81.094 mm. Uulitin ko lang yung ginawa ko kanina, solving for the value of A1 and A2, A1 is equal to 500 times 150. Value of A1 is equal to 75,000 mm squared. A2 is twice of 125 times A, 81.094. Then the value of A2 is equal to 20,273.50 mm squared. Solving for value of C1, 0.85. F prime C is 28. A1, 75,000, nakuha natin. Then the value of C1 is equal to 1,785,000 Newton. Same lang din to na nakuha nating value kanina. C2 is equal to 0.85, F prime C 28 megapascal multiplied by A2, 20,273.50 mm squared. Then the value of C2 is equal to 482,509.30 Newton. Solving for the value of Y1, tulad lang na ginawa ko kanina, yung total depth na to is effective depth or 725 minus 150 over 2 para makuha value ng Y1. Sa Y2 naman, this distance, effective depth, minus 150 minus 81.094 over 2. Kaya magiging value ng Y1 natin is equal to 725 minus 150 over 2 is equal to 650 mm. For Y2, 725 minus 150 minus 81.094 over 2. Then the value of y2 is equal to 534.453 millimeter. Solving for the value of nominal moment when tension controlled is equal to m1 plus m2. m1 is equal to c1y1 plus m2 is equal to c2y2. Meron na tayong value ng c1, c2 at y1 and y2. By simply substituting the values of C1, Y1, C2, and Y2, ang makukuha nating value ng MNTC is equal to 1418.129 kN meter. Using this formula, MUTC is equal to reduction factor MNTC. Meron na tayong value ng reduction factor, 0.9, at meron din tayong value ng MNTC. MUTC is equal to 0.90 reduction factor multiplied by 1418.129, the value of MNTC. Then, ang makukuha nating value ng MUTC is equal to 1276.32 kN meter. Since ang value ng MUTC is 1276.32 kN meter and MU or the moment capacity is 800 kN meter, papasok tayo sa criteria na to. MU is less than MUTC. Kaya yung classification ng beam natin is tension controlled. Ang gagamitin nating value ng reduction factor sa actual moment capacity is 0.90. From step 1, sinolve natin yung value ng MU max. Then kinumpaired sa MU. At na-prove natin na yung beam natin is i-design natin as singly reinforced. From step 2, sinolve natin yung value ng MUTC. At i-kinumpaired natin sa value ng MU. At na-prove natin na yung section natin is tension controlled, kaya ang gagamitin nating value ng reduction factor is 0.90. I-denote ko lang ulit yung shaded part as 1 at yung area niya is tatawagin ko A1. Step number 1, solve for MU of A1 or yung moment capacity na kayang dalhin ng area 1. This will be the corresponding stress diagram for MU1. Yung compressive strength under A1 is tatawagin kong C1. At yung value ng A is equal to 150 mm. Solving for value of MU1 is equal to reduction factor C1 multiplied by D minus A over 2. MU1 is equal to reduction factor 0.90. C1 is equal to 0.85 F prime C, area ng concrete. 0.85 F prime C, 28. Yung area ng concrete natin, since rectangle siya, 150 multiplied by 500 multiplied by D, 725 minus A, yung A na gagamitin natin is 150 mm over 2. Then, ang makukuha nating value ng MU1 is equal to 1044.225 kN meter. The value of MU is 800 kN meter. Minsan, dinedesignate din siya as MU cap, since this is the value of moment na kailangan i-carry ng ating beam. Going back to this figure, since ang moment na kayang i-carry ng area 1 is 1044.225 kN meter, pero ang kailangan na i-carry ng beam natin is 800 kN meter, it means na yung actual value ng A is less than 150 mm. Ibang senaryo naman ang mangyayari sa solution kung yung moment capacity exceeds the value of MU1. Dito na sa part na to papasok yung magiging depth ng actual A. Ito na yung correct stress diagram for the moment capacity of 800 kN meter. MU is equal to reduction factor C multiplied by D minus A over 2. MU is equal to 800 kN meter. Para maging Newton millimeter, ita-times 10 lang natin to the 6. Reduction factor 0.90 multiplied by C. C is equal to 0.85. F prime C, 28, multiplied by area ng concrete. Since yung area ng concrete natin under compression is rectangle, ang gagamitin natin formula is equal to A times B, 500. Multiplied by the moment arm, D minus A over 2. Then D is equal to 725. Ang unknown lang na value sa ating equation is A, kaya makukuha na natin yung value ng A. Then the value of A is equal to 111.62 mm. Applying summation forces horizontal, C is equal to T. C is equal to 0.85 F prime C AC. Take note, when you are working with non-rectangular beams, mas maganda na ang gamitin yung notation is AC. Kasi hindi naman palaging square or rectangle yung magiging area natin kapag hinati-hati natin yung composite section natin. Is equal to T, AS, FY dahil nag-yield na yung section natin because siya ay tension controlled. Actually, kahit naman pumasok sa transition region, FY pa rin yung gagamitin natin dahil nag-exceed na yung value ng FS natin sa value ng FY. 0.85 F prime C, actual area ng concrete under compression is equal to A times B. A, 111.62 yung nakuha natin, times B is equal to AS, unknown, times FY, 345. Then finally, ang magiging value ng AS natin is 3850.08 mm squared.